Hello, friends. Welcome back to the next session. Thank you for joining this session. Today we'll discuss. Today we'll discuss about something called as end-to-end AI lifecycle. So this is as an extension to understanding what are the core components of the AI lifecycle and how it has evolved over time. So we will do a whiteboard or a blue board kind of a session today. So most of our sessions will be either practical or these kind of extempore blue board sessions, so that we can discuss in a much more detailed manner and in an extempore manner, right? So without wasting any time, let us get into the subject. The topic is end-to-end AI life cycle.
Good evening, sir. I'm sorry, I'm late by a couple minutes.
Sorry, what was that?
I said I'm sorry, I'm late by a couple minutes.
No problem. We just started. So end-to-end AI life cycle. So today's topic is that I want you to take you 25 years back into a situation where we are trying to look at businesses, how the businesses were working 25 years back. And if I take any business, let me take a typical bank. So imagine 25 years back, if you're looking at a bank, and let me give a name for the bank as ABC Bank. Now, how the bank operated those days. So if you see, the bank used to have tellers, cashiers, and clerks who used to deposit money, withdraw money. You personally need to go to the bank for withdrawal of the money or deposit of the money, opening a fixed deposit, and things like that. And typically, all these transactions used to get stored into something called as operational data stores. So what are the transactions? The transactions are like opening a bank account, withdrawing money, deposit money. So there is a teller or a cashier who will be doing the transactions, and the transactions get stored into something called as ODS. ODS is nothing but operational data stores. Operational data stores typically used to be like RDBMS databases, relational database management system. So they are typically the SQL-like databases where you could store and retrieve information. And people used to query these databases to get analysis. For example, they employ a data analyst. And the purpose of the data analyst back then was to query these tables. So they used to write SQL queries. So these SQL queries used to be written on the ODSs or the operational data stores. Now, the typical these ODSs are like SQL tables like Oracle, MySQL, um, and PostgreSQL kind of things. So these are typical those kind of databases. So these SQL queries used to run on these ODSs and create some reports. Reports could be, which banks are operating with what margins. How much is the monthly average balance of a specific bank? How much withdrawals are happening? How much deposits are happening by region, by bank? So you can do such kind of reports by running SQL queries. These are typical select queries, and once in a while they used to do insert, update, and so on. But these SQL queries can create those reports, and those reports can be shared with senior executives for taking some meaningful decisions. Now, this used to be a typical scenario where the data analyst used to run these SQL queries, but at the same time, there are these transactions which are happening on the actual tables. For example, a deposit or a withdrawal and things like that. Now, when the transactions are happening at the same time and the SQL queries are running also at the same time, there used to be some kind of a bottleneck on the tables. There used to be little slow queries and all that stuff. So when people observed that, okay, there are some slow queries, we are operating during the business hours, and which is creating some problem for the actual transactions. So let us not run these queries during the actual business hours, but let us run the queries during the off business hours. Right? Imagine if I say the business hours are from 9 to 5 uh, in the morning, of morning 9 to 5, then the queries used to run in the night, and we used to call them as nightly jobs. They used to create something called as nightly jobs. Now, what are these nightly jobs? The nightly jobs are the same programs which run SQL queries. They also run SQL queries, but they are executed during night after the business hours. So if I take a typical business hours of 9 to 5, they used to run at say 8 o'clock in the evening, 9 o'clock in the evening, midnight, 12 in the night, so and so on. So these jobs used to run in that kind of a fashion where these the jobs can be executed at a different time, right? A different time in the night. Now, this worked for quite a long time. So I'm talking about 20-25 years back. So these nightly jobs were executed for quite a long time till uh, till the time when there are two major changes happened. Okay, the first one was the adoption of internet. First one was internet, and the second one was the geographical expansion, geo expansion. Now, with this, what happened is with the adoption of internet and geographical expansion, the companies had to come out of this typical 9 to 5 mode into a more 24 cross 7 available mode. For example, with the internet, people created websites, they created mobile applications. So the customers were no longer banking between 9 to 5, but they are able to bank at any point of time. They can bank at the midnight, they can bank early morning. So that was possible. And the second one was geographical expansion. The companies also expanded to other geographies. The company in US also opened their branches in Australia, Dubai, and UK and other parts of the world, which actually uh, because the combination of both of them has 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 kind of created this kind of there was no lean period, so we can call it as a lean period in sense the time where you could say that okay, no, the bank is not operating, and so that is the time where I can run my jobs. So there was no such lean period for executing our jobs. So you want to run the nightly jobs, but because of the internet expansion and the geographical expansion, there was no such lean period where I can go and execute my jobs. Back then, we created something called as data warehousing systems. To solve the problem, we created the data warehousing systems were created, the DWH. The primary purpose of the data warehouses is to extract the data from the operational tables and then load them into a warehousing table. The process is called as a popular ETL, extract, transform, and load. So you extract the data from the actual input tables, and then transform it if it requires some kind of a transformation, maybe removing some columns, doing some aggregations, loading them, all that stuff can be done. So extracting, transforming, and loading into the warehousing tables, DWH, are called as data warehousing tables. So the warehousing tables were created so that we can kind of decouple the actual tables with the warehousing tables. So after warehousing tables were created, these nightly jobs used to execute on the warehousing tables. Rather than running on the actual tables, they used to run on the warehousing tables. Warehousing tables brought two important advantages. First one is like it is kind of creating a decoupling. So the actual tables and the warehousing tables are decoupled so that my jobs can run at any point in time. So the role of data analyst increased, right? So they are able to create more jobs, more analysis reports, and so on. So that actually aggravated. And the second one was the data warehousing systems were also able to store a large volume of historical data, right? So the data, which is like you could store last 1 year data, you could store last 5 years data. So we could store historical data, which provided data analysts to do also comparative analysis. For example, I can compare how were the sales last year when compared to this month, right? How is the deposits last year when compared to this week? So such kind of analysis was possible with the data warehousing systems. And even today, we do have data warehousing systems very widely used. Some of the older companies still work on the data warehousing systems, and they are very good for doing this kind of business analytics where you want to create some reports, some dashboards, some kind of analysis outputs, and so on. For those things, these data warehousing systems are very, very suitable. Now, what happened after data warehousing systems, I would say around 2010 and so on, 2010, 2012, that time frame, where new kind of data sources started emerging. New kind of data sources in unstructured format, right? So that's when the data warehousing, if you see, data warehousing is primarily suited for structured data. It can nicely store structured data, data in terms of rows and columns and so on. But if it comes to unstructured data, it will not be able to store unstructured data, or it can store, but it is not efficient way of storing the unstructured data. So unstructured data was in terms of images, videos, and so on. So all such kind of data was kind of creating. In that point, people created something called as data lakes. Now, data lakes initially were created on something called as Hadoop systems, and and then eventually we expanded to other cloud systems like AWS, Azure, GCP, and so on. So these data lakes basically are now created where you could load these data warehousing systems onto data lakes, and the data lakes can also store unstructured data. Now, unstructured data could be in the form of videos. So you could load video data. You could load image data. If I talk about image, during my childhood, I only used to draw these two mountains, one sun, one river flowing, right? So image data. The other kind of data, for example, you could take log data. Logs can be system logs, operational logs, Then we can take textual data. And what else? We can also have sensor data. We can have sensors. A lot of IoT sensors started coming up. The sensor information and so on. So likewise, there are a lot of unstructured data sources which started, and these unstructured data sources would not typically following a structured data formats like data warehousing. And then they are like videos, binary files, image files, log files, text files, all such kind of files. They were used, and we could have pushed such kind of data and do a lot of analysis with that. So initially, it started, the name is big data, where we were able to do a lot of data storing, data storage, volume, variety, and all those things came into picture. And this particular area where we are doing a lot of data storages, analyzing, transforming, ingestion, and all this stuff will be taken care by something called as a data engineer. So this role is by somebody called as a data engineer, a person who is responsible for ingesting data, the person who is responsible for storage of this information, person who is also responsible for doing some kind of a transformation. Now, this is one kind of a role where we could do an entry level into the AI data science world. So, data engineer is one of the door. So, this particular session we're also discussing doors to data science, where we are seeing like what are the different doors. So, data engineer or data engineering is one door to getting into the AI space. It's a one easier door to get into the AI space. So once the files are stored, the next thing which is done is something called as a data visualization. Data visualization. And here the role is visualization engineer. And the purpose of the visualization engineer is trying to create some kind of a reports in a much more appealing manner. So the tools which are used are Tableau, Power BI, ClickView. You could write Python-based codes, Python-based visualizations, and so on. So these are all different tools which are used by the data visualization engineer. And their purpose is to visualize the data, identify patterns of the data, create reports for the senior executives so they can create dashboards. Those dashboards get updated with real-time data, and you can find out some patterns in that. So that is the purpose of the data visualization engineer. There is another
Can we,
role.
can we ask questions in between? Best to ask to the last.
If you have a question, put that in the chat window. Or
Okay.
if you have any question, yeah, you just let me know.
Yeah, just basically, you said the Python is for the data visualization. Is this a coding language, right? Python, or it's a front-end tool?
It is a coding language, but we can also create visualizations using Python. So there are libraries like Matplotlib, Seaborn, and other ones using which you can create visualizations.
Got it. So thank you.
So the next section is called as feature engineering. So feature engineering is again uh, kind of part of data engineer role, and sometimes it is a part of AI engineer role, where the purpose of feature engineering is before we do any data analysis, we try to extract and create features. Features are like output of your actual data. For example, you are you have a data you have a table called as transaction table. In the transaction table, every day you're spending, for example, today, imagine in a day, I will do some spending like every day morning, I will I will eat some breakfast somewhere, then I will go and have coffee. Then after that, in the lunch, I spend probably in the evening, I go for some shopping. Then I'll have some snacks. Then in the night, I go for a movie, and then I come back home, and probably and after the movie, I'll have dinner outside. So imagine these are my transactions for a day. So if you see, there are multiple individual transactions, like 1,000 rupees here, 500 rupees there. So you can see like the spend is individual. We do not want those individual transactions for analyzing any customer behavior. What we do is we aggregate per day or per week or per month kind of a customer spend. So you could just like add up all of them. So that is called as an aggregation, and the output which is created from that aggregation is called as a feature. So you can say a monthly customer spend feature, which can be used for analyzing the customer behavior rather than taking individual transactions of the customer. We generally do those aggregations so that those aggregations can be fed to the modeling to understand the customer behavior. That can be created by the feature engineering. The feature engineering, the output is multiple features of your data, and that will be fed to the central piece, which is called as modeling. So for modeling, we will try to make use of the data visualization. We'll try to make use of the feature engineering, and also the data gets fed from the raw data sources, the raw data lakes. So in the modeling, what we do, we have plenty of algorithms in machine learning and generative AI and other things. So we have something like supervised machine learning algorithm. We have unsupervised. We have generative. Then we have agentic. So here what we are seeing is in the modeling section where we have a lot of different types of algorithms are there, where these algorithms can be used for creating future predictions, right? So that is the modeling piece. So if you look at the feature engineering, there is a question like to explain it more. So as I said, the feature engineering is you create something called as features as output. What are the features? Features are nothing but the aggregations of your actual data. What is an aggregation? Summation of your data, average of your data. So you do not want individual transaction spend. As I told in the example, right? You every day I am spending something. So morning I spend some few rupees, afternoon I spend few rupees, evening I spend few rupees. So there are multiple transactions throughout the day. If I do like 10 transactions, you could take that column, which is like amount spend column, and I can do analysis on that, or I can build a model using that column. But instead of using that column, what you do is you sum up that column by customer. So for a customer, you would say like, what is the average monthly spend for the customer? Understood? You will calculate the average monthly spend for the customer. And that average monthly spend for the customer is called as a feature. Are we getting, guys? So that we aggregate and create an output of that data, and that data will be fed to the models rather than feeding individual transactions. For creating any analysis, for creating a model, we will do something called as aggregated output. Aggregated output can be you sum up all the transactions or you average all the transactions for customer for a week or for a month, something like that. And that is called as a feature, and that feature will be fed to the model. So as you see, this is the central piece. The central piece of modeling is where you have job roles. For example, you have job roles like data scientist. So the purpose of data scientist is, there are different data scientist roles, junior data scientist, senior data scientist. So these people will be creating, um, so let me use white only. So these people will be creating data science related models, applications, and so on. There is another role called as AI engineer role. AI engineer. And this role is basically where you're trying to create applications using generative AI, agentic AI, combination of some models. You can there will be a flavor of this called as Gen AI engineer role. So such kind of roles are also created, where the purpose is the engineer will be using one of these latest technologies like generative AI, agentic AI for creating applications or models. Now, many courses just concentrate on just this piece. They will just talk about different models. They'll just talk about generative AI, agentic AI, and just talk about those models. Of course, the models are the central piece, but as you are seeing, there are different connected pieces to it. Right after the modeling, the next phase is basically we call as deployment. So after the modeling is completed, then you will feed the model file. So model is, you could think like an executable. The model file will be fed via the deployment to the upstream systems. So there are two common deployment patterns. There is a batch deployment pattern and there is an online deployment pattern. Now, what is a batch deployment pattern? Batch deployment pattern could be executed in some kind of cloud. Maybe if I take an AWS cloud as an example, the batch jobs get executed. So you will upload the model file, and this batch job is executed in a timely fashion. So probably like every day, 9 o'clock, 9 p.m., there will be a trigger, the batch trigger, and this batch job will be executed. If I take an example, imagine every day we will collect the customers who are applying for loan, and all the customer detail will be aggregated. We will collect all the customer details and then feed a file to this batch program. So the batch program will get a file. Imagine it gets a file for 100 applicants for loan. So the model will predict out of the 100 applicants how many are eligible and how many are not eligible. And it will update the file saying that, okay, this customer is eligible, this customer is not eligible. So it will kind of mark. It will also give some reasoning like why the customer is eligible or not eligible. So that gets executed in a batch mode. So that this batch job, imagine it runs every day in the 9 p.m. Uh, Throughout the day, all the customers.
So we can't hear your voice.
Apologies, there was a blip in the internet. Are you able to hear my voice now?
Yes.
Yes.
Okay. So what I was talking about the batch-based job. Like the batch-based job can be having the core steps in which it will have an application. Maybe it is an application where it is trying to predict how many customers got approved and how many customers got rejected. And after that, there can be another downstream job which will be sending emails to applicants who got approved. So imagine my application got approved. I'll get an email saying that congratulations, Sitaram, your loan application is approved, and then you are getting so and so loan, right? So that is a batch process. So the business logic will be outside the model. The model is the one which is having the capability of doing the predictions, right? So it will have, we will train the model with a lot of past data, and using the past data, it can create those patterns so that it can predict what's going to happen in the future. So it will have the predictive capabilities. So for example, predicting whether the customer can be approved or rejected is a capability of the model. But the business logic, like entire thing, will be abstracted outside of the model. So utilization of the model will be in the business logic. So after I get the approved customers, what should I do? So I'll send an email or send a notification, WhatsApp message or whatever. So that will be your business logic. Understood. So in the batch process, we will just do it in a batch mode, and we will use a lot of things like any schedulers. There are tools like Jenkins and other ones where we'll be using, where we can automate all this process for the CI/CD pipeline for bringing the model, deploying into the cloud service, and all that stuff can be done by that. The second one is the online mode, and this is where, as the name suggests, you will have a real-time system. Imagine you have a website, and in the website you have some form. You can fill the name, age, salary, and other things, and click on a submit button. Right. So you fill all the details in the form. Imagine this is abcbank.com, abcbank.com. So that is the website. You go to the abcbank.com and then fill all the details for the loan application and then click on the submit button. Once you click on the submit button, there will be an API which will be invoked. The API will be invoked, and this API will be connected with the online model. So you'll have an online model, and the API will be providing the result in a real-time mode. So you click on the submit button, then and there the API calls the model, and it validates that customer and gives a result in in a real-time fashion. All right, so we have the batch-based deployment where you are trying to create the application in a batch-based mode. And there is an online deployment in which you are trying to execute the code in a real-time mode, then and there, like more like mobile applications, web applications, and so on. All those work using the online mode. So these are the two common methodologies. Of course, we also have something like streaming, which also comes as a online or closer to online. But these are the two popular mechanisms in which you do the deployment. Now, this deployment will be done by somebody called as a ML engineer. So ML engineer is a person who will be responsible for creating these deployment pipelines, taking the models into production, ensuring they are scalable, they are able to work take the load of all the people, and then it can have both batch or online based deployments and serving to the applications. All those things will be taken care by the ML engineer. Now, this person will be having some kind of understanding of operations like DevOps, and then they also do something called as ML Ops. ML Ops is what this purpose, like where they're trying to deploy the application, taking the model to production and doing all that stuff. That is the role of a ML engineer. ML engineer also does something called as monitoring. There is another piece which they do. It's called as monitoring. Now, monitoring is basically like after your model is deployed into production, how how is the model performing, right? So imagine you have deployed the model in January this year. Now we are in September and we are trying to figure out like how this model is performing. Is it performing as per the business requirements? Is it performing as expected or not? So that can be governed by the monitoring systems. We will create a lot of monitoring systems, and these monitoring systems will govern whether your model is performing correctly or not. There are two flavors of this monitoring, which is called as explainability. Explainability, and the second one is called as fairness. Explainability and fairness, these are the two things which will be typically used in the monitoring systems. And what they typically are required is, if explainability talks about if at all the model is taking some decision, on what basis the decision is taken, right? We need to explain why the decision was taken. Imagine somebody is given loan, we need to have some kind of a proof that why the loan was given, on what criteria the loan was given. So that explainability angle should be there. Now, the second one is the fairness angle, which talks about irrespective of caste, creed, any demographics, there should not be any bias in the model. So, for example, I am applying for loan, my wife is applying for the loan. Me and my wife have the same educational qualifications. We both work for similar organizations. Imagine my loan is approved, but her loan is rejected. Then there is a bias. We should not have any bias in my modeling or my predictions. So that is the fairness angle of it. So we do have a lot of metrics or parameters which can be monitored to understand whether the model is fair or unfair. The model is having equal opportunity. Model is having explainability and other things and so on. That is called as the monitoring. So these things are connected. Deployment and monitoring are connected. After this, there is one other area which is also quite important. That is called as the protocols. We call it as protocols. And two major things are in the protocols. The first one is the governance, and the second one is the quality. So governance talks about the rules in which the model is performing. It will actually gauge the business angle of it, right? What is the model doing? What is it predicting? How much business ROI it is generating? What is the impact of the model in the business parlance, right? So in the business parlance, in the customer journey or in the customer application, what is this model doing? uh, how this AI is helping. So those all things have to be actually monitored at a greater level. So that is where the governance thing comes into play. Now, while the governance will adhere to all the legal compliance and other stuff, but it will also try to gauge like how much is the revenue, how much is the spend, what is the model, uh, what is the performance of the model, and how it is giving many benefits to the business on the whole. So that work will be done by governance. And the quality, as the name suggests, it is like testing the models. Like they are ML testers, AI testers. The purpose of these testers is where we are trying to test these ML models. ML models should perform really well. They should be within the SLAs. They should create predictions um, which are absolutely correct. So for that, you need to have a quality team, and that team is responsible for ensuring that all these AI applications are performing as per the business functionality, so that they are following the functional requirements, non-functional requirements, and they're adhering to all the rules. So this is where the quality engineers come into play. So if you can have ML testers, MLTs, AITs, AI testers. These are the quality engineer guys, or the SDITs, the SDITs. All these come here. In the governance piece, you will have the product owners, product managers, scrum masters. So these are all the guys who will be working in this particular area. Right? I can. Right. So these are different roles and parts of it. So we have spent like what 45 minutes now, and my screen is completely full, and I don't have any space to write also. But I hope you are understanding the entire landscape now, right? So after this session, now you will get a decent understanding of the entire landscape. And one important thing which you have to concentrate is these circles, the red circles which I made for different roles, the data engineer role, data scientist role, visualization engineer role, AI engineer role, product manager, scrum master, ML engineer, ML tester. So these are the different doors to data science or doors to AI. So imagine somebody as a DevOps engineer. The good role for them will be ML engineer. So you, because they have an understanding of operations, they know like how DevOps is working, so that they can easily get into an ML engineer role, deploy ML applications, and then eventually become an AI engineer or a data scientist. Somebody who is having a development background, pure application development background, they can either become a data scientist or a AI engineer. Somebody who is having a data background, like data warehousing background, data engineering background, like they might be working in some kind of a Spark and such kind of data transformations. For them, the data engineer role will be better. So they can get into the data engineer role, and from there, they can eventually become a data scientist or a AI engineer. As you see, every role, there is an entry point. For somebody in a QA, they need to identify roles in ML testing or AI testing. There are a lot of roles in AI testing. The tools, whatever they are using, is the same set of tools which we use for application development. We use same like Selenium, the general load testing toolings, JMeter and other ones. So all those are the same tools, but how do we use them for AI models or AI testing is a little different. So for them, they should enter from that area. So you could enter from as an ML tester or a AI tester, and then eventually can become ML engineer, depending upon the understanding of DevOps, or else they can become an AI engineer. So they can come like this. They can become AI engineer or they can become an ML engineer in this kind of a fashion. But entry point will be this. Got it? So I'll just break for a minute. I want If you have any questions, please put them in the chat window, or you can unmute and then ask any questions.
Yeah. Hello, Sitaram sir. This is Satya from Boston again.
Hmm.
The last session, in the last session, right? So you mentioned uh, low code or no code, right? So since I came from data warehouse background and a Hadoop background,
Yeah.
do you think I'm fit into the data engineer role, or where I can
Yeah, yeah,
position
data
myself?
engineer to AI engineer. So this is the role progression which I see most of people are doing. Data engineer to AI engineer role.
Okay, so can you suggest me if there is any heavy coding involved or minimal coding involved or
There will
something like
be
that?
coding, but as I'm saying, our course will cover no code, low code tools also,
Mm-hmm.
where the coding is minimal. World is moving towards low code systems.
Okay,
So
yeah, yeah.
those are the ones which we will learn.
Okay, so it will be covered as part of this course, or
Yes,
do we need any other separate course
it
for
is
no
covered.
code and low code?
It is covered.
Okay, okay. So the best optimal role for myself, like my kind of self guys, is low code or no code for data engineer or AI engineer, right?
Hmm. Correct.
Okay. Okay, okay, sir. Okay. Thank you very much for the clarification.
Okay,
Yeah,
so this
hi.
question.
Hello, sir. I mean, this is Sridhar. Actually, similar question from my side. To I came from a Java development background. So what is the best area that I can concentrate?
Application development, if the people directly coming from hardcore application development, for them, data scientist or AI engineer, these are the roles which they generally target. These are core roles which will be focusing on application development, model development, and so on. So those are the roles which are very suitable.
And this course will cover both areas, right?
Both areas, yes.
Okay. Thank you.
So Sitaram, this is Purnand from New Jersey.
Yeah.
So where does a data architect or a on-prem or a cloud data architect fit in this model? And what would be next prospects for a data architect? A
Yeah, so
cloud
the
data.
data architect needs to have an understanding of this entire landscape, right? How the data ingestion happens, what type of data sources are there, the storage limitations for that, deployment limitations for that, all those things. So data architect needs to have an understanding of all these areas. Okay, that's one thing. And when it comes to cloud, so these are the toolings which are base requirements, right? This can be done in any cloud. You could do it on AWS cloud, Azure, or GCP. So how does the data get ingested into AWS? Which AWS tools will be used for modeling? Which tools in AWS can be used for visualization and deployment? So likewise, all those tools are can be done in all the cloud systems. So depending upon the requirement, the architect might need to have an understanding of the cloud also. Got it?
Okay, sir. Yeah, thank you. So like for a data architect, the cloud data architect, let's assume a GCP cloud data architect. Do the next evolution or the next steps would be to fit in as a AI engineer or a data
AI
scientist or
engine. Yeah. So,
yeah.
depending, that's what, if they are heavy on the data part of it, like data in
Right.
GCP also, they can be like a data engineer, ingestion and, working on the infrastructure and data storages and so on. For them,
Mhm.
data engineer and data scientist, those roles are better. If like their application developments on cloud, likewise, like then AI engineer is the best role.
So when you say application, it's like a front end application or a
Yeah, front end or back end doesn't matter.
okay.
Like deploying applications on cloud is one part.
Okay,
Working on data on cloud is another part, right?
right.
So if you're deploying applications on cloud, AI engineer is the role which will look.
Okay.
If you are working on data on cloud, then either data engineer or data scientist.
data scientist. Okay. Thank you, sir.
So there are a few questions on the chat. Let me answer them. So to recap, the batch online and monitoring governance tools. So, okay, on the right side, you want to quickly recap. So deployment is where once I have the model from the modeling piece, you will be using deployment for deploying into production. That will be done by ML engineer. Deployments will be in two patterns, batch or online. Batch is like regular job which is running on a scheduled fashion. Online is in real time, which is from a mobile application or a web application. Then comes the monitoring. So after you deploy, it's just like your job is not done. You just need to monitor the models, and the monitoring jobs can be created, monitoring systems can be created. There are applications for doing monitoring so that they can see like how the jobs are working in the real time. Likewise, you also have quality and governance. The security aspect also comes in the governance piece where, how do you ensure the model is performing to the best outputs and so on. That can be checked before and after. And before deployment, we will be doing the quality checks. After deployment, we will be doing other things like governance steps, business business productivity and profitability and all that stuff. Right.
Okay.
So
Sitaramji, you said security, right? So, was there any specific role for AI security, cyber security, or AI security
no specific role, they come in the governance itself.
governance itself? Okay. Okay. Got it. Yeah, so I worked in Hadoop administration, Cloudera, as like 9 years or 9.5 years. So security perspective, I know ACLs and other stuff. So if there is any, I mean, tomorrow after this course completion, if I can apply for a specific role like AI security or cyber security or something like that, that is, I think, more optimal for me. So that's why I'm asking actually.
Okay.
I mean, as you said earlier in the last session, we need to fit into one framework where it is optimal for our experience and previous knowledge as well, right? So that's why I'm asking. I'm sorry, I don't
Understood.
want to waste time, but I'm just trying to.
Understood. So I
Yeah,
think
yeah.
we will spend more time. So don't worry, guys. We will spend more time. If you are continuing, we'll spend a decent amount of time understanding all the flavors. For now, just understand that okay, this is the entire end-to-end framework where we are seeing. So let me answer the other question. So this course will be covering the core concepts of data scientist and AI engineer and ML engineer. So these are the spectrums we will be covering. Data scientist, AI engineer, ML engineer, and to some extent on the monitoring, fairness, and all that stuff. So those are the areas we are going to cover end to end in this course. Okay. I will touch upon data engineer a little bit because we need to know like how do you do data transformations and how do you feed the data to the models. So that will also be covered, but not in depth. The depth will be covered in data scientist, AI engineer, and ML engineer roles.
And in the governance area, like what tools are there? Do you have any idea for this?
There are there are tools. Some companies build in-house tools, but there are product tools like AWS provides their own way of governance and monitoring, and uh, and then there are tools like Neptune is there, Aporia is there, so which basically can do end-to-end governance of models.
Okay,
When
anything like Savient is related to this?
can you talk about what is it? What
Savient.
Savient, I have not worked with it, but let me do some research and come back.
Like identity access management tool.
That is different, right? So that is like for the identity access and so on. But what we are talking is like model performance and model this one.
Okay. Yeah.
Sir, here terraforms will come into the scenario, fit into any scenario in one area.
If you work with cloud, yes, we will be using Terraforms for deployments, but
Okay.
in general, no, not required.
And how about penetration testing, sir? In AI penetration testing, it is. I think I'm hearing that one very frequently. So penetration testing also covered
Will come
in
as
our.
the quality. Will come in the quality. Yes, it is also there. That will be
Okay.
coming in the quality part.
Quality. Okay. Quality. Basically, ETL, data warehouse, visualization, like Tableau, Cognos, or whatever it is, and then the core concepts of AI. Basically, it will be covered all this way, right?
Correct. Correct.
Okay. 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 Got it. Got it. Thank you, sir.
All
Sitaram,
right. So
I have
yeah.
an extensive experience in mainframe development, mainframe application development. Will there be any relevant scope here in this?
If you want to switch from mainframe to this side, you again application development. If you're comfortable with programming languages like even if it is COBOL or any other programming
Mm-hmm.
language, right? You will be able to get into the AI engineer role. So that is the easiest suitable role where you can switch into. AI engineer role work with Gen AI, agentic AI, and these new technologies which are being used. But you need to learn Python a little bit, which
Okay.
will be covered in the course. But you need to spend a little time on the Pythonic way of doing things and so on.
Gotcha.
And what is the difference between this agentic and generative AI? I mean, recently I am seeing more popularity for this.
That is the topic. Understood your question. That is the topic for today. So if you watch any soap serials, right, and they'll say like, please don't go away, come back tomorrow. That is the topic for today. Tomorrow.
Tomorrow, okay.
I have one question.
Yeah.
So, like, given this
Yeah.
course extensively covers the roles for like data scientist, AI engineer, and ML engineer. Say, for example, if I'm like primarily focused on becoming AI engineer, so the ML engineer concepts are still relevant, but it's not something that I like something that I need to like spend a lot of time on, right? Just making sure.
ML engineer is still relevant because AI engineer will build models and so on, but we still need to know like how do we deploy the applications, right,
Yes.
into production. So that'll not go away. So that role is there. We just have to what I mean to say, we just need to learn. Sometimes you need to learn a basic understanding. Sometimes you need to go
Yes.
in depth, depending upon the type of the company, right? If it is a small startup company, the same person will be doing data scientist, AI engineer, quality tester, ML engineer, everything will be done by the same person. Got it?
Got it.
Bigger companies have clearly separated roles, like deployment is separate, operations are separate, testing is separate, then data scientists are separate. So you'll have such kind of clear segregations of roles.
Yep. Got it. Thank you.
Hi, Sitaram. What's the prerequisite for this course? Do you expecting to have some sort of coding experience already? Because you sound like you are more leaning towards AI engineer, right? At the end, that is expected out of everyone, more or less.
Data scientist and AI engineer, yes. So these are the two roles. Again, I'm giving examples for type of roles. If somebody having a good data background, data scientist will be a best suit for them, right?
Do you expect to have
Somebody who
a
do not have a data background, you're getting right. Somebody do not have a data background, say like I have mainframe background, I am application Java developer, correct? So for now, for me to understand the data pipelines and all that will be a little overhead.